Hello. Good afternoon. So let's start this almost last session for today. I think everyone started after yesterday's karaoke. I will try to make it as fun as possible and not boring. The talk is called Ruby Mixology, but we're not going to drink today. We're going to mix some stuff into Ruby. Okay, let's go. Let's go. I would like to start with a question. Why Ruby is so impressive? Why it impress people seeing it for the first time, not even engineers, and continue impressing us, Ruby developers? The answer to this question lies in the very kind of a DNA of the language. And we can find it in the definition from the website. Half of it is about the elegant syntax that Ruby provides for readability and writability as well. And that's what makes the language impressive. But Ruby syntax and Ruby itself didn't come out of nowhere. It's a result of work of thought and some inspiration. Matt invented Ruby because I think so, at least. Okay, I need to confirm. But I think he was not satisfied with existing tools, first of all, with existing languages. And also, it was some kind of joy of problem solving. Designing a language that will be pleasant to use was and still is quite a challenge. And we're all trying to solve it. So Ruby has some traces to other languages, mostly like conceptually and semantically and syntactically to Smalltalk and Perl. But Ruby brought a lot of new stuff to the world of programming languages and continued evolving on its own. And the syntax is a part of this evolution. And if we take a look at the last 10 years of Ruby, that's about when I started actively using the language, we had a lot of small and not so small changes. I think 2019 was the most fruitful year for Ruby's syntax introductions. Not all of them made through to the final release, unfortunately. But still, there were good attempts to have them. And we'll probably come back to them later. Then we continued adding new syntactical features, small, big, and even in the next upcoming release, we already have one minor but really cool addition, an implicit argument for procs. But I would like to talk about what's going to be after that. So the evolution is not stopping here. We're going to have something new in the next 10 years, for sure, 20 years, whatever years we all live and see Ruby prosper. And that's not going to stop because language evolution is inevitable, and syntax evolution is a part of it. Why so? Oh, the answer is pretty simple, because if language is not evolving, it just joined the list of dead languages. And we don't want that fate for Ruby. So that's going to be something new, but the pace of this evolution may vary. It could look like this, like we can introduce some new stuff every year, every Christmas, all like that. And that's interesting how and why sometimes we have a lot of new stuff, sometimes just a few of them, or for many years we may use the same syntax as before. Let's take a look at some historical data and how some of the features made it to the release and when they were proposed. So for example, we had some features that had been kind of aging for a few years, not that long. Some features waited for more than 5 years to finally reach Ruby. And others, I think, yeah, the last one, were proposed and merged within the same year. So that's interesting how is core team, how is everyone involved into this process reason about adding new syntax when it's a good time to do that. And why it's not happening as soon as someone proposes it and proves that, oh yeah, I want its feature is useful, I would like to use it. But first of all, introducing new syntax is not easy task, because syntax changes are irreversible. once added, new syntax cannot be erased from the language. It's really difficult. You know, we have flip-flop operators still. We tried actually to remove it, but it's still there. And I think it's going to be there for a while. And to introduce a new syntax, we need to clearly understand that it's going to bring benefits more than conceptual complexity it brings. Because every time we introduce something new, it adds on the conceptual complexity of the whole language. So the question is how to figure out if a particular proposal, like syntax proposal, we're talking about syntax today, is going to be useful or not without even being able to use it. Because when it's still a proposal, it's just like a text written in the issue tracker, maybe a branch somewhere in the fork, but it's hard to use for a regular user, this new feature, and give feedback. So and that's the first thing we need to do when we want to evaluate new syntax proposals. We need to bring more people to experiment with it, to find corner cases, to share their use cases, their examples, because that would probably convince the core team and Demetyev himself to finally merge this feature. We're going to see some examples of that. But how to do that? How to bring proposals to all the community? And for that, I have the answer. That's called RubyNext. RubyNext is a transpiler and polyfill for Ruby, an award-winning software here in Japan. It helps you to use Ruby features, modern Ruby features, and upcoming Ruby features even on older versions or alternative implementations back to like Ruby 2.2, at least we officially support. And what's more important, it gives you some machinery to write your custom transformers or like rewriters, we call them, to experiment with new syntax, not yet available in the C Ruby or not yet supported by parser, like whatever parser you're going to use. You know, we have many parsers these days. So, since like this year, RubyNext also comes with this companion project called RubyNext Playground. So it's an online code editor specifically to work with transpiling and Ruby code. So it allows you to write some Ruby code, to define a rewriter for that. It could be as simple as something using regex. Why not? It's enough for experimenting. And of course, you can run this code. You can transpile it, see how it's going to look in your version of Ruby, and execute. So everything works, and you probably already guessed how it works. It built with RubyWasm. So this talk, kind of yet another talk about RubyWasm at this conference. And I think it's worth naming this edition of Rails RubyKaigi, RubyWasm-Kaigi. So we're going to use RubyNext Playground for interactive demos during this talk. Yeah, it's time to introduce myself. So my name is Vladimir, or Vova if you find my badge, or many people here simply use my GitHub handle, which is Palkan. I maintain many stuff in Ruby, so we probably heard about them. I wrote at a company called Evil Martians. Our Osaka team is here, and we're happy to share whatever you want to learn about Evil Martians, why we are evil, and what are we doing here in Japan, what's our plans, you know. And I have a book. Actually, it's here. What a coincidence. Helping me with my laptop. It's a book on Rails. It's currently not available in Japanese yet, but I hope it's going to be soon. If you can ask me anything about it, and I think I have a spare copy to share for nothing. That's all about like the advertisement blog. Let's move on to the actual talk. Okay, while I'm trying to drink some water, the bottles on the slide, on the cover slide, or on the one I shared on Twitter, depict many different programming languages. And I suggest you just taking a look and trying to figure out if you know all of them and can you recognize, because you probably could discover something new. That's pretty funny. Okay. So we discussed that one of the ways to kind of not speed up, but improve the quality of accepting or rejecting actually syntax proposal is to get more feedback by sharing this, make these proposals accessible to all the users. That's one of the options how we can evaluate the proposal. Another one, we can learn from other languages. So nowadays, I think it's hard to find a Ruby developer who's not using a second language, a third language, or whatever. So we're all writing software which relies on many stacks, many platforms, and so on. So we would love sometimes to see some features from other languages being somehow, not really ported, that's a bad idea, because every language is unique, but somehow resembled in our favorite language, in Ruby. And we had such example. I already mentioned it. It's a shorthand for hashes and keyword arguments. And it started way a long time ago, and it started with a quick rejection, from Mats, because we don't need it in Ruby, and JavaScript version is not yet so popular to consider it and rely on it or whatever. And a few years later, the position changed a bit. Like, okay, I'm ready for your opinions. Try to convince me. Maybe it's not that bad. Still, a lot of Ruby users use JavaScript. Yeah, that's true. Finally, a few years more passed, and Mats was convinced that, okay, yeah, let's do that. Well, he said that it's due to mandatory keyword arguments, but the community that insisted on having this feature, I'm pretty sure kept in mind the JavaScript use case, and they wanted to have something like that in Ruby. And I don't know whether you like this feature or not. I've been using it for many years already because it has been available for me for Ruby Next, and I really like it. So I'm glad we made it. So, okay, enough history. Let's take a look into maybe future and start mixing some stuff from other languages to Ruby. And the first language I'm going to talk about is this. So PHP. That's actually how I came up with the idea for this talk. I've been programming PHP before I found Ruby, so like 12 years ago. And, well, it was so-so language, like good enough. But I haven't followed it for years. And then I discovered this video showing how PHP evolved over the years. PHP is not dead yet, too, so it's also evolving. And one thing caught my attention, this operator. They call it Null coalescing assignment. And the idea that if the left-hand side is nil, or null, whatever they have in PHP, I don't know, I don't remember. We assign it to the right, the variable or key in the array, they call that arrays, to the right-hand side value. If it's anything beyond null, we do not make the assignment. So this is PHP version of this feature. There are other languages that have kind of similar functionality, like shortcuts for dealing with nil values. One example I would like to share here is Elvis operator in Kotlin. It's a bit different, and Kotlin is a very different language, but I'm sharing it here only for the syntax purpose. So what kind of operator we may introduce, because it looks like Elvis Presley. I like him. And JavaScript also has the same version of like null coalescing assignment on null and undefined in their case, actually. And that's an important bit. It's not surprise that we already have this proposal in Ruby Tracker. It's pretty old, still open, by the way, so it's not rejected for some reason. But, well, it looks like it actually should be rejected based on the discussion because there is no enough judgment to add this feature to Ruby. But I started to think about, okay, maybe we can take this idea of this operator and make it a bit smarter, maybe, make it a bit more useful, and that would justify this addition. And I started thinking about how we can add this to Ruby and what we can bring with it. Before I introduce the Ruby version of this feature, I would like to share a new syntax checklist with you. So what we should keep in mind when we think about adding some new syntax to Ruby. First of all, it should not be supported by the current Ruby implementation and should lead to syntax error. That's how we kind of gradually make our language more complicated. Okay. And first, more important, we must have use cases. We must justify the addition of this feature and the complexity it brings with it. And complexity could come not only from the semantics of the language, but also from the implementation. Some feature could be hard to implement and maintain in the future. Actually, implementation is not the most complicated part. Maintaining it later for all the life of Ruby, that's what's more important. So it should be easy to be picked up by the core team in case the original author decided not to support it. So after thinking about how we can bring this nil coalescing assignment, let's call it like this, we in Ruby, I came up with this version of this syntax. So just a questionable assignment, let's call it. And other languages have 2 question marks, but I decided to go with just 1 because having too many raises too many questions regarding your source code. And I don't understand why we have 2. So let's first check that it's not supported yet. Of course it's not. It's syntax error. This is how it can be used, like a kind of static version. So if something is nil, we can assign it to false, and then it's kind of not assignable this way anymore. Well, this static version is not really demonstrating the feature. Let's move to the RubyNext playground and try to see it live. So this is a working version of this operator built with RubyNext. And you can see, so we can assign it to false, and if we try to assign it to 1, nothing happens on the right side. If we use our regular conditional assignment, it works as expected. So that's kind of the use case, and the primary use case for memorization of potentially falsy values. And frankly speaking, I don't think that's enough for bringing this feature to Ruby. So that's kind of limited use case. So I started looking for more opportunities for this particular operator. That's where the fun begins. While reading this issue on Ruby Bug Tracker, I found a discussion that, well, what the original author wants is actually an ability to set a hash key if it's not yet defined, independently of if it's null or whatever. And it leads to a similar proposal called hash fetch set, which basically does the same, but it's not made it to Ruby. So I decided, okay, let's probably try this. Why not having this operator be a bit smarter and be kind of context sensitive? Because if we know that there is a hash key assignment, or whatever key assignment actually, we can rely only on aref node, that's how it's called internally. And if it's an aref node, we just check if the key is set and set it. So we can keep nil values inside. And it works. So that's another, well, maybe it's a bit magical, but still worth exploring. But the most interesting for me use case is using it with instance variables, which can lead to code like this. I don't know how do you often use the pattern of undefined instance variable and checking whether it's defined or not. I use it everywhere. And I would love to use a shorter syntax for that. Let's quickly see it in action. So it also works. So we know that we assign an instance variable. If we're directly doing this, not through the attribute accessor, that's kind of the edge case and the caveat with this syntax. And well, we can do that, right? So there is kind of a simplified version of a typical Rails application code when we have current user which can potentially be nil. And here if we use this operator instead of regular memorization operator, we see that the method is called only once. And if it's nil, it stays nil. However, there's a problem. Recently, Ruby kind of performance core team, I would say, introduced the concept of object shapes, and now they encourage us to not write code like this. I personally, I don't like the idea of rewriting kind of, I would say, idiomatic Ruby code, a popular pattern, just for the sake of some performance optimization, which is probably not as ready yet for, like, I mean, it's ready, but it's going to evolve, and probably we won't need this workaround, keeping in mind that we need to know about object shapes and not use this code. But anyway, as of today, I don't think that's going to be the main reason why this won't ever be accepted. Let's take a quick look at how the transpiled version of it works. So as you can see, for hashes, we check for, No, it's not working. Okay, for keys and for instance variables, we're just doing this define hack we write manually today. So we have some use cases, some esoteric use cases probably. The latest one is not really viable, but I'm waiting for smarter object shapes that would allow us to write Ruby as we did this all the time without thinking about the underlying implementation. And if we take a look at our checklist, we kind of pass, we obviously pass syntax error. We have some use cases, but not all of them are applicable as of today. And speaking of implementation, it's just a matter of tiny extension to Elixir and some parser stuff. So it's not doing anything like very complex. But that was just a warming up example. I wanted to demonstrate how we can reason about new features, how we can play with them, and how to kind of evaluate the potential of this new feature. Let's talk about more interesting language. I'm going to talk about Erlang. This is my second favorite language, and I'm happy to show you some Erlang syntax during this talk. If you have never seen it, this is how Erlang looks. So this is a popular Erlang learning like book, Learning Some Erlang, the best book I ever read on programming, even better than mine. And this is a canonical example of pattern matching in Erlang. We have pattern matching in Ruby, right? And I would say it looks better than in Erlang. Ruby expressiveness makes it even more readable because we can use ranges instead of guards, and that make everything like more concise. I like it. However, this is not the only way how we can write this functionality in Erlang. There is an alternative version of it, which use the feature of the language usually called method overloading or multi-dispatch. There is some difference, but we're not going to go into this during this talk, so I'm going to call it method overloading independently of whether it's compiled language, dynamic, whatever. So I think, well, I've been writing Erlang a lot, and I've been using this feature of the language a lot, and I really like it. And I would love to see something like that in Ruby. And I think that's a very natural continuation to the pattern matching feature we already have. We've already been using for 5 years. Wow, almost 5 years. So, of course, there is already a proposal for this feature. One, I think, the most detailed. But it introduced a new keyword and like def-b. I think I've seen something like that in some other languages, but I don't like the idea of adding this not really readable keyword like def-b, whatever it's def-b. We write in English with Ruby, right? So that's the weak point of this proposal. And there is also a recent kind of related proposal for extending endless methods to support arguments forwarding with pattern matching. It has an interesting discussion with some. It was already a branch for some kind of multi-dispatch based on this idea. But let's come back to our Ruby code. So, how could this code be translated into method overloading version, like without even thinking about implementation? Actually, in the same way it is implemented in Erlang. We can do it like that. So we can use existing constructs from Ruby. It's still the same def method name. It's the same in keyword and the pattern on the right of it. And that's basically it. Of course, it's not supported yet in the latest Ruby version, but we can bring it. Why I like this version of the syntax is, first of all, because no new keywords. The look of the feature resembles current other languages. The proposal that I mentioned before, the latest one, suggests having one def method name statement and multiple in statements, one after another, as kind of implementation of this feature. But I believe having multiple def method name repetition actually makes code more readable. You can clearly see what's going on and where are the boundaries of the methods. So let's see it in action. So we have the same method from the Erlang book, and we can see that it works. We can call it with different arguments and see different results. The latest clause with arguments forwarding is actually kind of else clause for this method. So we catch all, right? So if we want to edit, we edit. If we don't want to edit, it's going to be null method error when we call the function. That's exactly the behavior we want to achieve. Also, we can use keyword arguments as well in a very natural way. You see right now it's not supported. It just falls into the catch-all clause, but let's add it. And it's going to work in just a second. And here we use the common, again, pattern from functional languages, and we just kind of rewrote this implementation to already define clauses so we're not repeating ourselves. It's going to work with structs. It's going to work with anything pattern matchable, so it's not necessary just hashes and arguments. So with the current implementation I kind of sketched, we support positional arguments, we support keyword arguments. No support for mix of them. That's one of the challenges. And the question is whether we need it, whether we need to make syntax more complex to support this use case. Probably, if you use method overloading, you should probably stick to either positional or keyword arguments, and that's it. And there is no support for guards, because again, I think Ruby is expressive enough to not use them. And adding them would not bring any value to readability. And also, we already have examples of like pattern matching functionality, like in operator, like a one-liner, and so-called like right-hand assignment. They do not support guards either. And the good thing is, this feature works perfectly with all the Ruby object model features, like modules, inheritance, whatever you can do with methods. It works with pattern matched or method overloading like this. So we can, for example, we can inherit our class with overloaded method, override the method without any patterns, always patterns if we decide it's not a problem to. And it's going to work because there is one important implementation tip also borrowed from Erlang. So how could this be implemented? Yeah, I built it somehow, but well, if we want to bring it to Ruby, we need to think thoroughly, especially of this multi-method with the same name thing, right? Because we have like method tables and all that stuff internally, and refactoring all this to support multi-dispatch would mean a huge amount of work. We don't need it. So I took a look at Erlang. So we have two versions of the same functionality written, one with case statement, another one with method overloading. And it turned out that under the hood, they compile into the same bytecode, like literally one byte, like byte by byte. There is nothing, just a syntax sugar. So it's purely syntactical feature. It doesn't affect the underlying method lookup mechanism, method calling mechanism, whatever. So this is how it's implemented right now. Okay, this is Ruby 2.5 version. We need to transpile pattern matching. You see it's complex. But with Ruby 3.3, it looks like that. So a bit of checks for arguments, and then it's just a case statement like we did before. So if we can do this under the hood and pass it further to the compiler, then we're done. So this is just a matter of kind of restructuring the source code. So yeah, we pass all the checks. I'm pretty sure, I'm not sure about the use cases. So I came mostly from Erlang. That was my first professional language. So I would love to use this feature. People not familiar with this feature probably still like maybe not sold on adding it, but I would recommend to try. So we have a few minutes left, and I have a few more stuff to propose, but we're going to do them a bit quickly. So we're going to mix a lot of stuff in Ruby at the same time, in the same section. And it's going to burn. So, yeah. So, the first one. Also, something that has been proposed multiple times, making it possible to set instance variables right in the method definition. You know, we have many libraries trying to implement this to avoid writing these initializers with a list of instance variables assigned to like positional argument. And yeah. well, the first proposal was like 11 years ago, and it's mentioned CoffeeScript, popular among Ruby's back then. But CoffeeScript had that. Nowadays, Crystal has that too. And one more surprising language that already had that is actually Ruby. Because in Ruby before 1.9, it was possible to declare instance variables as arguments right in the block. So not using blocks, not using def statement, but using blocks. So it kind of was a workaround for that. So a typical example, which could be rewritten with this feature, is this, right? So that's it, simple as that. We can use keyword arguments as well. Why not? It's not a problem, just adding colons. Or we can use additional arguments if we want to add something not to be set to instance variables. So yeah, let's wait for it to come. Yeah. One thing I've keep in mind that probably we should limit this functionality only to the initialize method, and that would probably make it more less like shoot yourself on the foot thing than adding it to every other method. I think we can do that. Another idea I have in mind, which is probably too radical, is to having this one-liner. If you don't need to avoid this, end on the next line. Anyway, so this is another thing that, and I hear there are plenty of use cases when this feature could be useful. We just need to figure out the implementation actually, because there are some edge cases with like default values relying on instance variables, how we can use them. There are dependencies that could probably either should be prohibited or would require some refactoring, maybe major refactoring. Okay, well, let's continue our Blitz overview. Anonymous struct. That's an interesting proposal. It's already 4 years old, and fortunately it didn't made it to Ruby because we couldn't find a good notation for it, right? So there were some proposals, but they were not kind of good enough to finally add this feature. So I just Googled anonymous struct and found that Zig language has this feature. It works pretty differently. It's for just the main purpose of it is to omit typing information. But we can take a look at the syntax they use for that, right? So not thinking about how it works. Also, it turned out that JavaScript has a similar proposal. And it's really similar because it allows to create immutable objects. And our anonymous struct actually should be renamed to anonymous data, which is also allows us to create, well, not really immutable, but frozen objects. So I decided to try Zig version and use it with Ruby. And this is how it looks like. Well, under the hood, it generates a data class based on the list of the keys and creates a data object. So if you use the same set of keys multiple times with this anonymous, let's call it struct anyway, object, they're going to be of the same class. So that's one of the reasons for introducing this feature instead of, say, open struct or struct new pattern used in many places. Yeah. Okay. So if we change the set of keys, it's just going to be a new class, and because we rely on the set of keys here. So this is how it could look in Ruby, and you can try using it and see if this dot brace notation is good enough. I found it pretty readable. Okay, yeah, so also it's mostly, this feature would rely on parser changes and standard loop changes because we need to deal with this smart, I would say, caching of classes, or maybe not caching on something more sophisticated. Finally, Elixir. I added in my title probably, right? But we haven't talked about them. So what's the most wanted feature from Elixir that Ruby community tried to add to Ruby for many years? It's pipe operator. Yeah, this happened just a few days ago. We had another Ruby developer said like, hey, we need it. Well, pipe operator. we're basically out of time because, so I would suggest you to implement it. But I'm not giving you without any hints. Yeah, there was already one proposal for pipe operator, and it didn't went through. And I think, because I think it was not as powerful as it could be. So let's take a look at this code using Ruby 3.4 already with it. And I think it is actually a key point that could bring this pipe operator back to Ruby. Because we can translate this currently working Ruby code into this using it. And the thing here is that whenever a right-hand side has it defined in the top-level expression, we do not pass anything as an argument. And whenever it's not present, we just pass the previous value as the first argument to the function. So that makes this pipe operator, well, useful, at least for this use case. I like it. That's the last example. You can try to implement it yourself. I don't have a working version yet. Just to summarize what I was trying to do here, instead, except from like keeping you here while everyone is eating fruits. I suggest trying to be more active in syntax discussion, proposals discussion, especially if you have some examples based on your libraries, your applications that would benefit from introducing this feature. Share them. And especially if you have some confusions or edge cases not yet noted by the author or core team or whatever, whoever is responsible for adding this syntax. I combined all the stuff I talked about today in a single RubyNext kind of example. And you can see here how it looks in the transpiled version. It's available here. So there's short link. You can open it. It has a lot of rewriters, and it's a bit slow. It's not really optimized for performance, but it works. And I think that's it for today. I have stickers, actually not I, but my colleagues. And thank you very much. And thank you, Emma, previous speaker, for helping me with Japanese subtitles. I hope they help you to better understand what I was trying to talk about today. Thank you.